Okay. So, okay. So, okay. 3rd May. Okay. 3rd May. Okay. 3rd May. So this is where your exam is going to happen for the NEET. Okay. So what we will do, we will practice some of the most important previous year questions that NEET have repeated multiple times. Okay. So at the last moment, this is the only thing that you can do. Keep on revising the formulas. Do not forget any simple formula and solve the questions from here and there wherever you can get from. All the previous year questions you should be updated with. Okay. So just in that series only, I'm going to try to put some input from my side so that it can be beneficial for you also. So first question, the velocity will be given as a function of time, t square minus 2t. So these type of questions are again very popular. So velocity as a function of time will be given. They can ask you the positive displacement, how much, or acceleration, how much. Okay. So for acceleration part, what we are going to do, here velocity is given as a function of time. So acceleration will be given by rate of change of velocity with respect to time. So differentiate it to get the acceleration. So 2t minus 2, this is our acceleration. Whatever time they are asking, at whatever time you will put the value of time in this expression, and from there you can easily calculate the value of acceleration. Acceleration, by the way, is linear in time. It's a variable acceleration case. Here, if they are asking displacement, let's say displacement they are asking between 0 to 4 seconds. How much the particle will displace between 0 to 4 seconds. So in this one, what you will do? So we know that displacement is given as integral of v dt from 0 to 4. So velocity function t square minus 2t, 0 to 4 t square minus 2t into dt. So after integrating it, you will get t cube by 3 minus t square, 0 to 4. We'll get here 64 by 3 minus 16. Whatever this one will come, that will be our displacement. Okay. So these type of questions are very popular in NEET. One function is given, they will ask you another question, another function. Let's see next question. So here velocity is given as 4 root x. Velocity here is given as 4 root x. So velocity is a function of what? Position. Velocity is a function of position. If mass of the particle is half kg, what is the value of force acting on the particle? Mass of the particle is half kg. Velocity is varying with position as 4 root x. So what will be the force acting on the particle? Okay. So here we know that acceleration is given as v dv by dx, because here velocity is a function of position. So instead of dv by dt, we'll use this formula of v dv by dx. Okay. Velocity 4 root x into d dx of differentiation of velocity, that is 4 root x. So 4 will come outside, it will become 16 root x. Differentiation of root x is 1 by 2 root x. So root x cancel, 8. Acceleration is coming out to be how much? We got the acceleration 8. Mass is given half kg. So force will be mass in times acceleration. Mass half times 8. So what is the value of force? 4 Newton force will act on this particle. Okay. Moving to the next question. You drop a particle from this point, it is sliding angle theta. So after how much time it will cover this length L? How much time it will take to fall down? So we just need to calculate the acceleration in this direction. And now we have drawn free body diagram so many times that we already know the force acting in this direction will be mg sin theta. So acceleration along the plane will be how much? Force by mass, that is g sin theta. Okay, g sin theta. Now it is covering L distance along the plane with what acceleration? G sin theta. So how much time it will take? Root 2 a by L. So root 2, sorry, root 2 L by a. Root 2 L by a. So root 2 length, how much you have to cover L? Acceleration, how much you have? G sin theta. This is the time taken to fall the over the L length. In the same question, they can ask you about with what velocity it will reach the ground. When it will reaching the ground, what will be its velocity? So velocity formula is root 2 gh. In kinematics we have studied. So instead of g, it will be a, and height how much it cover? L along the incline. So root 2 g sin theta into L. Okay, next question. Y equals to 2x minus 5x square. This is the equation of a projectile. 2x minus 5x square. Equation of the projectile is given. So they are asking what is the range and h max of this projectile. What will be its range and maximum height of this projectile? Okay. So this question is important because we are going to solve it without any formula and anything. So this is y versus x. It's a projectile. So the graph will be something like this. Okay. Equation of this graph is how much? Y equals to 2x minus 5x square. At the top point, there is a special point at the h max. So special point about this point is that tangent at this point will become horizontal. So slope of the tangent will become 0. Slope of this tangent will become 0, and slope of the tangent is represented by dy by dx. So dy by dx will become 0 at the topmost point. So dy by dx equals to 0. So we can say that differentiated dy by dx. By the way, it will give you this value of x, this coordinate. Okay. So differentiated dy by dx. So dy by dx will become how much? 2 minus 10x equals to 0. 2 minus 10x equals to 0. X equals to how much? 1 by 5 meter. So we got this x equals to 1 by 5 meter. Now this is the x that we have got here. This is the x. So by symmetry we can say that this distance will be equal. So up to here half it is x. So total will be how much? 2x. So range will be double of the x. 2x means 2 by 5 meter. Range is how much? 2 by 5 meter. Okay. H max. Now for H max, what we'll do? For H max, we have the value of x. Here we have x coordinate at this point. X coordinate is known. We'll put that x coordinate in the equation. It will give me the y coordinate. That is this distance. And this distance will be H max. So whatever x I have got, I will put the x in the equation here. So I will get our y coordinate, h max. So h max will be equal to, putting it back in the equation, so we'll get 2 into x, how much? 1 by 5 minus 5 into 1 by 5 square. So 2 by 5 minus 1 by 5, that is 1 by 5 meter. H max equals to 1 by 5 meter. Okay. Okay. So let's move on to the next question. Mark down again, very important question, JMS PYQ. So suppose from the incline a particle is sliding. A particle is sliding along the incline. This one is a smooth incline, so mu equals to 0. And a similar incline we have where we have refractive index mu. So same particle is there, it is sliding down the incline. In both the cases, inclines are same, length and everything is same. Only thing is that here first one it is a smooth and second one it is having friction. So tell me which one will take more time to fall? Friction one. A smooth one, here it will grab, here acceleration will be more, so it will take less time. So this time taken t dash and this time taken t. It is saying that t dash equals to n times t. In friction, it is taking how much time? N times as compared to the smooth case. So what will be the value of our n? Uh, what will be the value of this refractive index? N is given. N times it is taking. Okay. Now, if you do not remember this type of questions, it will become very difficult to find out at that same moment by solving it. So it's better that you keep these cases in mind. Okay, first one, acceleration will be how much? When it is falling without friction, acceleration will be g sine theta. And in the second case, when it is falling with friction, acceleration will be how much? Acceleration will be g sine theta minus mu g cos theta. This will be the acceleration. Okay. Theta here, let's say 45 degree. Theta also given, let's say 45 degree. Okay, t dash. So how much time it will take? Root over 2 L length it is falling, acceleration g sine theta g by root 2 minus mu g by root 2 equal to n times, how much time it will take in this case? 12 upon g by root 2. Okay, so 12 we cancel inside root, we can square it. After taking LCM, it will be root 2 times g 1 minus mu equals to n square times the root 2 by g. Okay. Okay. Yes. Almost n square. So that's root 2 by g, root 2 g by cancel. So we'll get that 1 minus 1 minus mu. Take the reciprocal, I will get it 1 by n square. So mu will be 1 minus 1 by n square. So this will be the coefficient of friction if it is taking n times. Okay. Moving on to the next question. Block and string problems have been asked multiple times. So let's quickly see how to solve these questions. Suppose we are pulling the block by 100 Newton force. This is our 5 kg block, and or this is a 4 kg block, and this is 6 kilogram block. So what will be the tension acting on the string which is present in between the blocks? Okay, again, this one is a simple question. Directly you have to remember this case. So at this point you need, so at this point you will draw the line. This side is our left side, this side is our right side. So what is the formula here? Left force into right mass. Left force into right mass plus right force into left mass divided by total mass. Okay, this is a formula. Keep it in mind. Multiple cases we can apply for this formula. Left force right force left mass divided by total mass. So let's see directly calculation of tension at this point. So here left force, no force is there, so 0, right mass 0. Now right force 100, left mass 6. So how much you'll get? 600. Right force left mass divided by total mass 10. So what will be the tension and between the rod in the string will be 60 Newton. How much tension will get? 60 Newton in between. Okay, if I want acceleration, so acceleration is net force by net mass. So acceleration is 10 meter per second square. Now you can check it also whether it is working or not. This 60 Newton is coming or not. Let's see that. Acceleration we have to create 10 meter per second square. So in our 6 kilogram block, let's say we are applying T force. So T should be equals to 6 into acceleration, how much? 60. And that is coming. So in order to produce 10 meter per second square acceleration, tension must be 60 Newton. It means our formula is working, right? Okay. Let's solve more questions based on this one to enhance this formula. One block, two block, three block. Here we have 500 Newton, 2 kilogram, 3 kilogram, 5 kilogram. So what will be the tension in this one? T1, and tension in this string, in this part of the string T2. So what will be the value of T1 and T2? Okay, value of T1 and T2. Quickly tell me fast. Voice and all clear. Hello. Hello. Yeah, voice is clear, I think. Hello. Yeah, voice is clear, I think. Okay. So let's see the solution of this problem now. At this point you want. So if you want at this point, what you gonna do? Left, right, same thing. So this is our left side, this is the right side. Left force again, no force here. So left force will be 0. So right mass 0. Now right force. How much force is acting on the right side? 500 Newton into left mass, how much? 2. Right force into left mass divided by total mass. Total mass how much? 10. So 100 Newton. This is our T1 value. T1 value is how much? 100 Newton. Okay. Similarly, if I talk about the value of T2, force acting in this part of the string. Let's see T2. This T2 will be again right force, left mass. So now see carefully. If you talk about this side, left side, how you will take the both the mass of the system, not only 3 kilogram but 3 and 2 both. So left side, the right force 500, left mass 5. Left force absent, no problem. Divided by total mass 10. So answer will be 250 Newton. Okay, 250 Newton. Okay, next problem based on the same as concept. Two blocks are hanging with a pulley 5 and 10. So what will be acceleration and tension? How much acceleration and tension? Okay, so let's see. Downward force will act how much? 100. Okay, now this is our string. So here this side we can take this force, right force, left mass. So tension will be right force 100, left mass 5, 500 plus left force, again left force 0. So no need to do it. Divided by total mass 50, 100 by 3 Newton. Acceleration if you want. So net force is 100, net mass is 15, 20 by 3 meter per second square. Again you can check this acceleration, or you can check this tension with respect to this acceleration. So let's see, this is our 5. 5 is experiencing a force T. Okay, so T should be how much? Mass into acceleration, 5 into 20 by 3. And how much will come? 100 by 3 Newton. And that also we are getting with our direct formula. Okay, so these are the pulley mass systems. Let's see some vertical cases also. No vertical cases. This is a pulley, downward 4 kilogram. On this side we have 6 kilogram. Okay, now same acceleration and tension we need in this case. Acceleration and tension. This side force how much? 40. This side force 60. Acceleration will be given by net force. So even though these 60 and 40, they are like, they feel like they are in the same direction, but they are opposing each other. 60 is pulling 40 away. So they are kind of opposite forces. So net force will be 20. 60 minus 40. That will be net force 20 divided by net mass 10. How much acceleration it will create? 2 meter per second square acceleration it will create. Okay, now tension. So for tension you can draw the free body diagram of any object. Downward 40, upward tension T. So it is going upward. So T minus 40 should be equals to 4 into 2 mass into acceleration. So tension must be how much? 48 Newton. Either from 6 kilogram or from 4 kilogram, you will get the tension same. That is why it is ideal pulley. This is one of the property of ideal pulley. Tension on the both ends remains same. Okay, next question. In projectile, one question is asked. One question has been asked in J mains. There is a person who can throw a ball maximum up to 100 meter. Maximum how much he can throw? 100 meter. Highest. So a person can throw highest up to 100 meter. So what will be the farthest he can throw? How much far he can throw the same ball? Okay. Question is clear. A person can throw a ball highest up to 100 meter. So how much farthest it can throw? So let's see that if you want to throw something highest, if you want to throw something highest, okay. So for highest, you will throw it vertically upward. This concept you might be knowing already. If you want to throw something highest, so for highest, okay, just a minute. There is some problem happening with the streaming. Expected resolution 1920 180. Okay, no problem. Aspect ratio I had to change. I don't know why they are asking, but okay. Let me check now. Is it okay? Okay. Now, okay. So let's see this question now. Highest, how much it can show? It can throw 100 meter. So if highest is 100 meter, can throw. Farthest, how much he would be able to throw? So for high throwing it highest, you need to throw it vertically upward. So vertically upward height will be u square by 2g. That is 100. The farthest means range. Range formula you all remember, u square sine 2 theta by g. Okay, so maximum range, if you talk about, it will happen for theta 45 degree. So theta must be 45 degree. So 2 theta will become 90 degree. Sine 90 will become 1. Maximum range will be u square by g. That is the farthest how much you can throw. This one only will be called farthest. So u square by 2g is 100. So u square by g will become how much? 200 meter.